Hello everyone. In this problem, we will try to calculate the moment due to the force. Let us try to see the problem. Determine the angle alpha. You have to determine the angle, what you can say alpha, or you can take it as theta. So they have given now. Here they have given one angle theta. So which is going to vary from, that is theta, it is greater than or equal to 0 degrees and less than or equal to 180 degrees. For the force 200 Newton force, we have one force of 200 Newton force. It has to be inclined at an angle such that angle has to vary from, or it has to vary between 0 to 180 degrees, so that it produces maximum movement about A. This is the point A. Now about this point A, it has to create maximum movement. That is first question. Second question is, it has to create the minimum movement. It has to create the minimum movement, right? So in this way we have to apply the force. So now at what angle this has to be applied? So that is the question they have asked. So if you see, if you are going to apply the force, for example, now this I will draw one line joining this point AB. So if I am going to apply the force, F is equal to 200 Newton, which is perpendicular to this line AB, then it is going to create a maximum moment. Then it will create a maximum moment. So based on this, let us try to calculate the angle. So let us try to take this angle as alpha. This angle as alpha. So then next this angle will be, if you see this angle is alpha, means this total it is 90 degrees. So if this is alpha, means this remaining angle has to be 90 minus of alpha. 90 minus of alpha, correct? Then next, if you take this AB, if you take this line AB, so this is perpendicular to the force 2000. That means this total angle is 90 degrees. If this is 90 minus alpha, so this has to be equal to alpha. This has to be equal to alpha, right? So as this is alpha, this has to be equal to alpha, right? So the first, let us try to calculate this value of alpha, right? So therefore tan alpha will be equal to this angle tan alpha. We'll try to calculate this tan alpha is equal to 5 divided by 3. So therefore tan alpha, that is equal to 5 divided by 3. So based on this, alpha will be equal to, you can say 59.04. 59.04. Then next is, we will try to calculate this theta value. This theta value. So theta will be equal to 180 minus of alpha. Theta will be equal to 180 minus of alpha. That is equal to 180 minus of 59.04. Therefore, this will be equal to 120.96 degrees. So this force has to be inclined at an angle of 120 from this face, or from here it has to be inclined at an angle of 59.04 degrees. Then next, if you want to calculate the moment now, maximum moment, that is force into perpendicular distance, we have to take force into the perpendicular distance. So if you see now, this is the line, this in this way we will apply the force. This is the line joining this point. So now this distance has to be calculated. As we know this side 3 meters, this side is 4 meter, we can calculate this length. So therefore, what you can say, this length AB will be equal to square root of 3 square plus 5 square. 3 square plus 5 square. So we will be getting answer as 5.831 meters. 5.831 meters. The next is, we will try to calculate the movement. We will try to calculate the movement now. We know the force. We will try to calculate, that is movement about point A, that is equal to, force is 200 Newton. This force is now 200 Newton. This force is 200 Newton multiplied by this distance, perpendicular distance. This distance is 5.831. 5.831. So therefore this answer will be 1166.2. Unit will be newtons and meters. So if you see this force, it is going to cause a anti-clockwise movement. So you can write it as, you can show the direction anti-clockwise, or you can show the negative sign here. Right? So this is the first case what we had solved. We have tried to calculate the maximum moment. Then next is they have said us to calculate the minimum moment. So now how to calculate the minimum moment? So what happens is that let me draw the figure here. So this is the triangle we have. At this point one force is acting, so we have, this is the line joining the force, we have to apply the force F is equal to 200 Newton in such a way that the line of action of the force, if it is going to pass through this point A, if the line of action of this force, if it is going to pass through point A, then there will be no movement, there will be no movement, this will not create any movement, that will be the minimum moment what we can have. So therefore now this distance is 5 meters, this distance is 3 meters. So this angle they have given it as, what you can say, this angle is theta. If this is theta, we can have this also as a theta. So we will try to calculate now at what angle it has to be applied. So therefore we can calculate this angle theta. So how do you calculate now? This is the second part of the question. That is minimum for, what you can say, minimum moment, for minimum, what you can say, moment, we can have this, that is tan theta will be equal to, tan theta will be equal to, what you can say, 3 by 5. Therefore theta will be equal to 30.964, 30.964 degrees, 30.964. And what will be the minimum moment? So m minimum will be equal to 0. Why it will be equal to 0? As line of action of force, line of action of force, it is going to pass through point A. Line of action of force is passing through point A, passing through point A. So therefore it will not create any movement. So this will be the minimum movement.